Similar triangles, problems, finding two unknowns. You already know that when we have a pair of similar shapes, we can use the scale factor k, a length on the copy divided by a length on the original, to work out the relationship in size, or lengths, between the two shapes. And that when we have an unknown on one of the shapes, we can multiply the scale factor by its corresponding value on the other shape to find the value of the unknown. The reason that our scale factor is always copy over original, and we always make sure that the shape with the unknown that we're solving for is our copy, is that makes sure that we can always multiply by the scale factor to get our answer. Some questions have an unknown variable, 1 on each of the shapes. And actually the most consistent way to solve this is to find the scale factor twice. So I'm going to start by finding x, which will mean that the smaller triangle is my copy. The scale factor is the copy over the original. Choose. Now you have a look at what you've got when you're doing these questions. I only have numerical values for one pair of corresponding sides. So I'm finding x, my 12 is the value on the copy, over 16. If you need to use your calculator to simplify 12 over 16, do so, but I would expect you to be able to simplify that by spotting that 4 goes into the top and the bottom, and so by dividing the top and the bottom by 4, we'll get 3 over 4. Absolutely leave that as a fraction. One of the things that you must start doing in 9a and 10a is leaving any fractions in improper fraction form if necessary. It's much easier to work with than a decimal or a mixed number. So we've found the scale factor, and now x is found by doing the scale factor times the side that corresponds to x, which is 5. Now this is 3/4 times 5. You can grab a calculator if you want. 3 over 4 times 5. That will give you 15 over 4, which you could have worked out. This is a whole number, that's 5 over 1, and when we're multiplying a fraction by a fraction, we multiply the numerators, 3 times 5, it's 15, and the denominators, 4 times 1 is 4, and we get 15 over 4. If you get that answer and you want to evaluate to a decimal, the 2 arrows here will get you 3.75. So 3.75 is a very sensible answer because we had number answers here and we're looking for lengths. I don't have units, maybe they're meters. 3.75 meters is a very meaningful number. But anything that you have to keep on doing any maths with, keep it as a fraction if it starts out as a fraction. So we've found x. Now we want to be able to find y. You'll notice that when I'm finding two different things, I say what I'm doing. I am finding x, I'm finding y. I keep my working very neat. Now we want the scale factor, k, copy over original, when this triangle is the copy, because now I'm trying to find y over here. So that's 16 over 12, which comes down to 4 over 3. Leave it as 4 over 3. Y, then, is the scale factor, 4 over 3, times 3. Now you have a couple of options for doing this. You can multiply your fractions out the same way I did, 4 times 3 on the top and 3 times 1 on the bottom, which would give me 12 over 3, which would say y is 4. Or you could recognize that you have a 3 here and a 3 on the bottom, and so you can cancel the 3's, leaving that as 1. 1 and 1. 4 times 1 is 4, 1 times 1 is 1, 4 over 1, is just 4. So being able to manipulate fractions competently and confidently is a really useful trait. Yes, you could just do this with a calculator, but you're not building up your skills in using fractions. Now, we had a bunch of people with concerns about this question in the booklet. It's a pair of overlapping similar triangles, and we are finding x, which is not a full side of this larger triangle, and y, which is a full side of this small triangle, but is not a full side of the larger one. A strategy that I really want to stress here is anytime you have any sort of challenging question, redraw the triangles so that they are separate and aligned the same way. So for this one, they're aligned the same way. They haven't been rotated, but they're not separate. Redraw them as two separate triangles, and it makes life a lot easier and a lot clearer. So this is triangle AED. The larger one is triangle ABC. And label what we know. So this is 12. Now, this side in the larger triangle is 12 plus x, and this side in the larger triangle is 5 plus y. So now we can ignore this diagram altogether and try to solve the problem based on this. What you have to look at is what information you have and what you want to find. Because you can't actually just start this out going, oh, well, I'll find x first. It doesn't work like that. You might have to find a side that isn't x at all in order to get x. Look at what you have. I have one pair of values which are corresponding sides. And that's great because it tells me I can find the scale factor k. I have one value which is a side length apart from that, and that tells me which of the other sets of sides I can find. So this is great, I've got a scale factor from these. This says I'm going to have to find side AC first. It's the only thing I can find, so I start with that. To make it easier, you can always call this side something like Q. You can't call it X or Y, but anything else is fine. Another perfectly valid name for this side, by the way, would be little b, because a side is often named after the capital that belongs to the letter of the capital that belongs to the angle opposite. So this side is opposite angle B, so I could call it little b, but let's not get too carried away with that at the moment. So we can find Q. First I need my scale factor, k, copy over original, and I'm finding Q. I needed to know this, what I was finding, before I did the scale factor, because that's whether it's 9 over 12 or 12 over 9. Because this is the copy, it will be 12 over 9, which we should be able to simplify down to 4 over 3. Leave it as a fraction, mixed number, the improper fraction. To find Q, then, it's the scale factor, 4/3, times the corresponding side to Q, which is 12. Again, use your skills with fractions to recognize that you can cancel a 3 out of the 12. 12 divided by 3 is 4, 3 divided by 3 is 1, so 4 times 4 is simply 4. What have I done wrong? 4 times 4 is 16. Sorry. So Q is 16. Now I can find X because Q equals 12 plus X. 16 is 12 plus X. X equals 16 minus 12, which is 4. Sorry, I was getting ahead of myself in numbers. So we've found X. That's great. Finding Y is going to be a little bit more challenging because I still don't have a number on a corresponding side to Y. I have Y, which corresponds to 5 plus Y. So to find y, we're going to have to be a bit clever. And this is, quite a challenging aspect of the question. If this would be an A-grade level question, if you feel you need to just focus on the rest of your studies, you could stop here if you want. Because we don't have a corresponding for y, side or value for y, we use the proportion statement. So side AE over side AB, we're used to writing proportion statements now, is going to be the same as side ED over side BC. Substitute in what we know. AE is y, AB is 5 plus y. That must be equal to ED 9 on 12. I have not done this as easily as I could. This would have been slightly easier if I put AB and BC on top, making this the copy, but I understand that that's not likely to be how we think, so this will work as well. Now what we have is an equation, but it's a really nasty equation. We have to know all the rules of solving equations, such as if we have an unknown on the bottom, we have to deal with that really early on. I've got y divided by 5 plus y. I need to get rid of that divided by 5 plus y, which means multiplying both sides by 5 plus y. And that will be 9 times 5 plus y on 12. I'm going to need to get rid of this divided by 12 here. 12y is 9 outside of 5 plus y. Need to expand this. Excuse me. So 9 times 5 is 45, 9 times y is y. Group your unknowns together, so subtract 9y from both sides to get 3y equals 45, y equals 15. All that to find y. And side AB is 5 plus y, so this would be 20, but we won't ask you to find it. It is a tricky question that pulled in similar triangles and quite a complicated equation solving strategy.